Okay. Okay, perfect. All right, let's recap. Before we even talked about this stuff Friday, let's talk about just a polygon. Can you remind me what a polygon is? It's a shape, yeah. Okay, be a little bit more specific. Like, is this a polygon? Why is this not a polygon? Okay, well, yeah, so my not perfect drawing is not closed, but nor would that be, right? Why not? Yeah, no vertices, which is just plural for vertex. So a polygon's got to have a bunch of straight sides, and it's got to be a closed shape. There can't be any curves or anything like that. Can you tell me, what do we call a shape that has 9 sides? Nonagon. Y'all are getting better at that one. Good. And I'll tell y'all when y'all need to start writing. Although, I tell you what, if you don't know a 9-sided shape, then I do want you to write that down. 9-sided shape is a nonagon. Tell me about a 4-sided shape. Okay, quadrilateral. Tell me about a 6-sided shape. 6-sided hexagon. Tell me about shape with 7 sides. Heptagon. I would say that 9, 6, and 7 are easily confused among people. So, what about what? Okay, what is 10? Decagon. Very good. But these are the ones that I definitely wanted to review. Okay, 10 is deca. What about, let's do 12. Dodecagon. I don't know what you just said, but it was not right. I'll tell you that. You're close. You're close. Okay, so then we talked about this idea of convex and concave. Concave. And basically, the difference between the two. Does anybody remember the difference before I tell you the difference? Okay, something about interior and exterior. I'll give you a hint. A convex shape looks like this. And a concave shape kind of looks like this. What's the difference? Mm, that's just my poor drawing, Waylon. Wait, say that again, Ella? Okay, that's an interesting way to look at it. I'll say this. If I color the middle of my convex shape and my concave shape, here's how you tell the difference. Sorry, I know the screen blacks out. Okay, here's how you tell the difference. In a convex shape, I've never heard this before, but that was kind of neat. She said it's kind of tame. So if I were to trace over the sides of that shape like this, and sorry, I'm not perfect. Do you notice how my lines just extend and, you know, life goes on. Nothing special happens. For a concave shape, though, notice as I trace over the sides, what is the difference? It goes through the colored stuff, right? It goes through the center. So concave shape is like if a shape caves in. So if you color on the inside of your shape, then you've got a concave polygon. Convex, it's just very clear cut and simple. It does not go through the center of your polygon at all. Okay, now let's talk about, someone said earlier, interior and exterior angles. So this is, if you haven't written stuff down yet, this is where I definitely need you to start writing some stuff. Okay, interior angles, every single one of you knows that the word interior means on the inside. But there's a formula that we can use to help us solve for the degrees for interior angles. What is it? times 180. Fantastic. N minus 2 times 180. And basically what this is doing is if I ask you a question for, let's do an example. Let's do total interior angles, and you can abbreviate these. I want to know what are the total interior angles of an octagon. I want to know the total interior angles of an octagon. How would I find that out? Very good. So 8 minus 2 is 6, and then what is 6 times 180? 1080. So 1080 degrees are the 8 angles of an octagon. Now, what if I asked you a different question? What if my second example said, find measure of one angle of a regular octagon? I have to put the word regular in there. Who remembers what that means? Yes, and all of the, yes. So when I say the word regular, it means all angles and sides congruent to each other. So particularly, what is a great example of a regular octagon in everyday life? And UFC, is that what you said? No. A stop sign is an octagon. So, and that's the example that I'm looking for. It's perfect, right? All the 8 sides are the same length. The angles are the same measure. Okay, so if I asked you for one angle of a regular octagon, what would you do then? Well, so we already did step 1, right? N minus 2 times 180. But since you already know that that is 1080, then what is 1080 divided by 8? 135 degrees. So that, right, so that would mean all 8 of them would be 135 degrees. Now, if I just had any 8-sided shape, that's not necessarily the case because I could have different sizes. Okay, my last example dealing with this is find the measure of an exterior angle of a regular octagon. And again, you can abbreviate these questions if you like. Find the measure of an exterior angle of a regular octagon. Can y'all still see the screen? Oh, I was just asking. I covered it up? Okay, don't worry. Here you go. Find the measure of an exterior angle of a regular octagon. Okay, how is this question different than the other ones? Okay, and exterior doesn't really have a formula. Like interior has n minus 2 times 180, but what is exterior? No, 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 that's not what you do. Nope. The exterior angles all add up to something no matter the shape. Yeah. So in an exterior angle, we have to remember that the exterior angles for any shape will always add to 360 degrees. Whether it's an octagon, a quadrilateral, a parallelogram, a nonagon, whatever, it will always add to 360. So what do I need to do to find an exterior angle? Divide by 8, right? And just means I want one of them. So what is 360 divided by 8? 45 degrees. 45 degrees. Okay, so that's how to do interior and exterior angles of any shapes. Parallelogram. Okay, on Friday, you guys talked about parallelograms. Y'all, the biggest thing about parallelograms is that it's in the name. Literally, the base part of this name is parallel. Okay, so there are 4 qualities of parallelograms that you should have learned on Friday. Can you give me those 4 properties of a parallelogram? Or what are some things? What's parallel, Waylon? Awesome. So we'll say opposite sides are parallel, and there's something else. They're not just parallel. Say again? I mean, they do have adjacent sides. That is true. Someone finish the word that I'm typing. Opposite sides are parallel and congruent. Okay, tell me about opposite angles. They're what? Well, consecutive is different than opposite. Opposite angles are totally across the shape from each other. So like this one and this one are opposite. Do you want to take a guess based on my picture? Opposite angles are congruent. So opposite sides are parallel and congruent. Opposite angles are congruent. Y'all, angles can't be parallel, right? Because linear things are parallel. Okay, now this was the word that somebody just threw out. Consecutive angles. What's another word for consecutive angles? The same, is that what you said? Okay, so maybe let's do same side interior angles. So consecutive would be like, in the same parallelogram, and again, forgive my terrible drawing, but instead of the angles opposite of each other, like these two next to each other would be consecutive angles. So tell me about consecutive angles in a parallelogram. What are they? Do they look the same? The two that I just drew? No, that looks like an acute angle. This one looks like it's an obtuse angle. So they're not the same. Do you want to try to finish my sentence? Fabulous. They are supplementary, which is the fancy word for that they add to 180 degrees. Okay, so opposite sides are parallel and congruent. Opposite angles are congruent. Consecutive angles, or you can call them same side interior, right? And this is just one example. This is one example. The top 2 angles are another example. The right 2 and then the bottom 2 are all considered consecutive angles to each other. Okay, the last thing was about the diagonals. The diagonals. Diagonals in a parallelogram connect opposite angles. So like these 2 segments that I just drew are considered the diagonals. Yeah. This one's a little bit more challenging because it's not one that you really think about, so I'm going to give it to you. The diagonals bisect each other. Exactly, which means they cut each other in half. Fantastic. So this was stuff that you should have learned on Friday. These 4 main topics. I went through a few examples with you in the video, and then hopefully you did decently on your homework and solved for different sides. So there's a lot more to parallelograms than meets the eye, particularly if I just drew this shape, you could not say, hey, that's a parallelogram. First of all, because it's a terrible drawing and I don't have straight lines. But secondly, in order for something to be a parallelogram, you have to see evidence of one of these four pieces of information here in order for you to say that it's a parallelogram. What I have here is not enough for you to conclude that. Okay, so that's kind of the challenging part of this chapter. Does anybody have any questions on parallelograms? Okay, so let me, how do I want to introduce this to you? What? Yeah, so do y'all have a sheet that says special parallelograms? Okay, awesome. Okay, this is me. Okay, can you give me some names? Let me give myself some hair. Hold on. Okay, can you give me some names that I go by? No. No one in their life has ever called me Triangle. Yes. Miss Schwanier. Miss, I don't even know how you would spell that. Schwani? Schwani. What else? Not really. I refuse to go by Miss C. Bro, nobody calls me bro. Miss, you're right. I get called that a lot. Did you say Your Honor? Allie. What else? Did you say mom? Yes. I have been mistakenly called mom by plenty of students. No one calls me sis. Well, okay. Some people call me sister for sure. I'm not a nun, but I get called sister. Any others? Saints lover? I mean, nobody greets me that way, but okay. Miss Saints lover. Miss Saints lover. Any other names? I mean, like we could just do my full name, right? Okay. Now, obviously you don't have to write these things down, but look at all of my different names, okay? I respond to most of these. Miss Saints Lover's questionable. Schwani doesn't really happen in any other class other than 7th. None of you really call me Allie, at least not to my face, and you shouldn't. This is kind of typical for my job. So here's the deal. Did you say Trisha? Okay, here's the deal. When you guys were little kids, and it's funny, Harrison has, do I not have a shape thing? Harrison has, those toys where you like put the building block shapes in the bucket and you have to fit, it's like a little puzzle, you know what I'm talking about? You know what I'm talking about? Yeah, they're still pretty fun, I agree. So when little kids learn shapes and they see this shape, what is that shape? It's a square. Now, you guys are a little bit smarter than you were when you first learned about squares. What else do you know about squares other than what I've drawn? Okay, so we know that all four sides have to be equal. What else do we know? They all have to have 90-degree angles. They all, well, not really. 360. Now, here's the deal. You don't learn this stuff when you're like 2 or 3 learning about squares, but now you know these features. I want to scroll up here to my list of parallelograms, and I want to ask you something. Does this hold true in a square? Are opposite sides parallel and congruent in a square? Yes, all 4 sides are the same, so that means the opposite sides are the same, and they're parallel. What about opposite angles in a square? Are they congruent? Yeah, because they're 90 degrees, all of them. So of course opposite angles are congruent. What about consecutive angles? The same side angles, do they add to 180? Yeah, because in a square, if you've got, your two top angles or your two side angles, 90 plus 90 is 180. And then we don't really look at this one much, but if I drew the diagonals, would they cut each other in half? Yeah, they would. And even though my picture's not pretty, they would. So what does that mean? Can you give me other name? We know this shape is a square, but can you give me another name for it? Quadrilateral. Oh, cube would be, that's a good guess, but that one would be for 3D. So that would be, if you have, oh yes, okay, you're correct. For the shape thing, those are three-dimensional shapes. That is true. But I just want to talk about two-dimensional now. So I just want to talk about this square here. Okay, square, quadrilateral because it has four sides, right? Can you name something else? Polygon. What did I just take you through? The qualities of what? What did these stand for? Hello. These were the four properties of a parallelogram that you learned on Friday, and I took you through it, and you said that all of them were also true for a square, which means technically, if a little kid saw a picture of a square and was a genius and called it a parallelogram, which my son might be here in the near future, I'm just kidding, they would be right. Parallelogram? I did not spell that correctly at all. Parallelogram. Gee, that's pretty terrible. Okay, so do you get my drift here? That a square has lots of other, just like I have a lot of names, so does a square. And today we're going to talk specifically about other types of parallelograms. So, oops. Shoot. Children, I need you to focus. Okay, I spelled parallelogram incorrectly, so I need to rewrite that. Parallelogram. Okay, so here we go. I need you to have your special parallelogram notes out, and I'm going to blank out the screen here for just a second. Okay, so children, hey, remember me? Okay, I'd like to try to teach you something. This special parallelogram sheets, you need not lose it because we're going to go over it over the next few days. Like, we're not filling out this whole thing today. Today, we're only focused on the top parts. So here we go. The top part of this should be a little bit easy because we discussed this already. Special Can we learn? All right. Special parallelograms have all of properties of parallelograms, which are the four that we just discussed. Opposite sides, you should be able to fill these in now. Opposite sides of a parallelogram are what? The parallel and what else? Parallel and congruent. Parallel and congruent. What about opposite angles of a parallelogram? Well, maybe I'll put that on here. They are congruent as well. Consecutive angles. They are supplementary, which is the fancy word. If you prefer, you can put add to 180 instead. They add to 180. And then what do the diagonals do? They bisect one another, which means they cut each other in half, or another way of thinking about it is they bisect one another into two smaller congruent segments, right? If it cuts it in half, then that means the two small segments are congruent to each other. Okay, so there are three types of special parallelograms. They have these four properties, but they have additional properties that make them more special and ultimately are given a different name. So, rectangles are our first special type of parallelogram. Do you agree that rectangles have opposite sides that are parallel and congruent? Yeah. Opposite angles in a rectangle. If a rectangle also has, what are some qualities that you know of a rectangle before I even go over them? Hold on, I heard a bunch of nonsense. Right, and we know that, right? So that's what I just checked off. Okay, so they're parallel. What else? It is a polygon. Its diagonals bisect each other, all these things. So, rectangles have two additional qualities other than these four. Okay, the first one is this. Tell me about the angles of a rectangle. Yeah. Don't think so hard. A 5-year-old could tell me this. Patrick isn't the only one that can answer. The four angles of a rectangle. What are they? Children, come on. And specifically, if they're equal, they have a number. All four angles in a rectangle are 90 degrees. Easy, easy. Easy, easy. Okay, here's the other thing. The diagonals not only bisect each other, but in a rectangle, the diagonals are congruent. Okay, they are congruent. So here's what that means. Name one of the diagonals for me. DB. So DB, if they're congruent, then DB is congruent to what? AC. Okay, if they are congruent, and up here we also know that they bisect each other, then that means they cut each other in half. So then that means we can also say that if DB was cut in half, then DE is congruent to what? Not AB. Nope, that's the same thing, just backwards. If DB was if DB was cut in half, then DE must be congruent to EB. And if the diagonals are the same, then that means the other two segments are also the same. So then that means AE, those are congruent to AE, which is congruent to EC. Does that make sense? C. Okay, so what we're going to do next, and that's it. That's all of our notes for today. So what we're going to do next, woohoo, is I'm going to blank out the screen for just a second. So if you're still looking, relax. Yes, because we're going to add to this paper tomorrow, so I don't want you to lose it. Okay, what we're going to do is look at file printout. Do they have the rectangle sheet as well? Okay, so look at the 6-4. Okay, do you see that sheet up on my page now? Great. So what we're going to do is I'm going to guide you through a couple of examples on this, and your job is going to be to finish it. So let's look at, I'm not going to do all of them, but look at like the group of 1 through 6. Notice there are no numbers on the picture, but in the directions it says find each measure if. This should say the measure of angle 1 is 37. So what I want you to do is at angle 1, I want you to put 37 degrees. Okay? All of the other numbers are referring to angles. So if angle 1 is 37 degrees, what else do we know? Did somebody say about angle 3? Yeah, it's going to be 37 as well, because these two triangles like this, because of all the properties that we know about a rectangle, those two triangles are actually going to be congruent to each other. So angle 3 is 37 degrees as well. 2 is another easy one to get. What else can we do for 2? What do you... Yeah, if the corner angles add up to 90, then what is 90 minus 37? 53. So angle 2 is 53 degrees. You see, so that one's kind of like a puzzle. So then you can use what you know about those angles to find all the others. Okay, skip down with me. Those are easy. Y'all can finish those later. If you look at this next group, these have a little bit of algebra in it. So I'm gonna do 8 and 11 with you. Okay, 8 and 11. So let's look at number 8. Number 8 says if RZ equals 3x plus 8 and ZS equals 6x minus 28, find UZ. So the first thing I do when I get to problems like this is I label my picture. I need to know what the heck am I even, too much zoom. What the heck am I even trying to solve for? All right. Okay, let's label our picture. RZ is 3x plus 8. So as best you can, and if you can't fit it on the picture, you can put it like 3x plus 8 like this with an arrow to it. And then it says ZS is 6x minus 28. So ZS is 6x minus 28. Find UZ. Now, I didn't read this, but in bold it says quadrilateral RSTU is a rectangle. For all of these, for 7 through 12, it's claiming that it's a rectangle. What part of the rectangle are these segments that I'm labeling? No. Like, what is RZ and ZS? Like, what parts of the rectangle is that? Yes. Okay, so they're parts of my diagonals, and the diagonals were bisected. Okay, so if the diagonals are congruent and bisected, what do I know about these two segments then? They're what? They're equal. So if I know in every rectangle, guys, and you could mark this on every single rectangle if you want, all 4 of these internal segments like this are always going to be congruent. So if they're congruent, the question is, what is UZ? Well, UZ is this highlighted part here. That one is congruent to the other 2. So if I find one of the others, then I could find UZ very easily. Then I know the other one, yeah. Now, if I know these are the same, though, I've got to set them equal first. 3x plus 8 equals 6x minus 28. And then I need to solve for x. So again, remember, all of you algebra in different ways, and so do I, and there are literally 4 things that you could do. No way is more correct than the other. Just know that you have to get x by itself. So I like subtracting 3x from both sides, leaving me on the left side with 8 equals 6x minus 3x is That does not tell me what that is. 6x minus 3x is 3x minus 28. And then if I want to get x alone, I'm going to add 28 to both sides. And what is 8 plus 28? So then I get 36 equals 3x. And then if I want to get x alone, I divide both sides by 3. And what is x? Now, that's not the answer, right? Because the question is, the highlighted part, what is uz? So what do I need to do with x? Okay, and I can plug it back into either one because all four of those are congruent. So instead of 3x plus 8, if I plugged in 3 times 12 plus 8, what is that? What is 3 times 12? And what is 36 plus 8? 44. So that means uz is also equal to 44. What? That's okay. Just draw arrows to show that you're swapping them. Yeah, and just show me that you knew that they were opposites. Okay, so those are dealing with the diagonal. So actually, let's go ahead and do I want to do 10 or 11? 10 or 11? 10 or 11? Let's do 10. So Patrick, just write your work in the opposite spot. So notice this one's giving us some different information. It says if the measure of angle SUT equals 3x plus 6 and the measure of angle RUS is 5x minus 4, find the measure of angle SUT. So what I like to do in these is kind of shade the area of the angle that I'm looking for. So it says S to U to T is this angle right here, right? That's SUT. And that is 3x plus 6, the blue stuff. Then angle RUS, if I connect the dots, R to U to S, is this angle right here. And that is 5x minus 4. Find the measure of angle SUT. So that's the blue stuff. What do I know about these two angles that I just shaded in? Yeah, they add up to 90 degrees because this is a rectangle. So I know the corner angles will add to 90. So literally do that. 5x minus 4 plus, oops, not 99, plus 3x plus 6 is equal to 90. And then again, this is just an algebra problem. So if I combine my like terms, 5x plus 3x is 8x. Negative 4 plus 6. Okay, so 8x plus 2 equals 90. And then if I want to solve for x, it actually becomes really simple. I'll subtract 2 from both sides. And then I get 8x is equal to 88. Fabulous. Now, again, that's like step 1, right? And this is where geometry gets tricky. That's step 1. Oh, I don't know. Did you must have added 2. Even if you added 2, that should be 11 and a half. Did you do 10 maybe? Okay, listen, focus, listen. Okay, you should get x equals 11 if you do your algebra correctly. But the question is, what is the measure of angle SUT? Well, SUT, given in the problem, is 3x plus 6. But you know x is now 11. So then we can do 3 times 11 plus 6. So what is 3 times 11? 33. And then 33 plus 6 is 39. So then we can say the measure of angle SUT equals 39 degrees. So it's not so bad but the thing is you have to know these characteristics of rectangles though in order to know how to set them up. Say again? Okay, hold on. I'm not there yet. Does anybody have any questions on 8 or 10 yet? Okay, awesome.